The rectangular coordinate graph of r equal g of theta is shown. For part A, sketch the rectangular coordinate graphs of r equal 1 plus g of theta, r equal 2 plus g of theta, and r equal negative 1 plus g of theta. So as we look at these are just vertical shifts. This one is just the graph of this function moved up 1. So let's go ahead and do that. Let's move this one up 1, and this one up 1, and this one up 1. So it would look like this. And then we could put on r equal 2 plus g of theta, and that would just be shifted up 2. So up 2, up 2, and up 2. So that would look like this. And then let's go ahead and put on r equal negative 1 plus g of theta. So that would be shifted down 1, down 1, and down 1. So that one would look like this. So as we look at these in our rectangular world, this adding 1, adding 2, or subtracting 1 just has a vertical translation. How does that affect the graph in the polar world, though? Because part B, we're going to see that. We're going to sketch the polar graphs of these now. So we're going to start with the original one that was there in red. So let's go ahead and draw a polar graph here. So as we look at this, we see that at 0 we're going to be at 0, so we're going to be right here, and then we are going to increase, and at pi over 2 we're going to be at 1, and then at pi we're going to be up at 2. So let's go ahead and make some little scale tick marks here. And so we're going to be increasing. At pi over 2 we're going to be at 1. By the time we get to pi we're going to be at 2. So we're going to increase, come around like this. Now we're going to have an abrupt change here. This just turns and goes back the other way. At 3 pi halves we're going to be at 1, and then we're going to be back to 0. So we're going to be here at 1 and then back to 0. So we actually get a cute little heart on its side. Looks more like a heart than a cardioid does. Now let's see what happens when we have the vertical shift of up 1 in the rectangular world. So that's the green one. So at 0 we need to be at 1. And at pi over 2 we need to be at 2. And then at pi we're going to be out here at 3. So as we come around here, it looks like this, and then we see that we are back to 2 and then back to 1. So it would look something like this. So very interesting. A vertical shift of 1 in the rectangular world is an enlargement here. We can see in our scale that we make this larger in the polar world. So let's go ahead and graph r equal 2 plus g of theta. So at 0 we are at 2. At pi over 2 we are at 3. And at pi we're at 4. Then we're back to 3. So we can see what we're doing here in the polar world. Okay, very interesting. So you should be able to predict what the graph is going to look like when we have a negative one. Now let's try it. So at 0, oh, this is going to be interesting though, because we are going with a negative radius here. So at 0 we're going to be at negative 1. So we're going to come over here. Then we are going to go increase, and when we get to pi over 2 we are going to be at 0. So remember, as we go from negative 1 to 0, we were over here doing angles in quadrant 1, this first piece here, but we're doing this negative radius, so we end up being over here in quadrant 3. So this is going to come around here till we get to 0, and then we are from pi over 2 to pi going to increase to 1. So we're now going to, from pi over 2 to pi, we're going to increase to 1 right here. And then we are going to decrease from pi, we're going to decrease to 0, and then we are going to go to -1. So that's actually going to trace that out again. So the interesting thing here is we lose that little kind of point heart-shaped thing, and it ends up almost looking like a teardrop instead. Very interesting vertical shifts and the way they transform things in the polar world.